this video, we will move to the example of the rectilinear kinematics problem for the case that acceleration is not constant. Okay, for the case that acceleration is not constant, we have to use the basic kinematic equation that is there's ds by dt equal to v, dv by dt equal to a, and v dv equal to a ds. Okay, we have to come back to this three basic one. Okay, and we cannot use the formula that is we just use for just only the constant acceleration, such as v equal to v0 plus at, s equal to v0 t plus a half at square, and v square equal to v0 square plus 2as. This formula is for constant acceleration. Okay, and it cannot apply right now because the acceleration is not constant. Okay, so we have to use this, come back to this equation instead, and we have to use calculus for differentiation and integration. So you have to review the basic calculus. Okay, for the first example, we will starting with the basic one, that is a particle travel along straight line to the right with the velocity of v equal to 4t minus 3t squared. You see that the velocity function, now velocity function is the quadratic function. So then if we take the derivative of this equation, is we will get the acceleration that it is not constant. It should be the linear function of time. So this problem is not a constant acceleration problem. Okay. So t is time in second, and we know that when time equal to 0, s equal to 0. Okay, this is important things. This is the initial condition that we have. That's the problem give us. Okay, and we have to concern on it. Okay, we would like to find the position and acceleration of the particle when time equal to 4 seconds. Okay, so then let's start with the acceleration first. Okay, we can take a derivative of v, of velocity, to find a, okay, to find the acceleration. That is, we know that a equal to dv by dt. Okay, and for this case, we know that v is equal to 4t minus 3t squared. That is, we take derivative of this function. It's a polynomial function that is very easy to take derivative, right? And it's from this we get a, the acceleration function is equal to 4 minus 60. Okay, that's all that we have. The acceleration function is 4 minus 60. You see that the acceleration is not constant. Okay, it is a function of time. And when we stop still, t equal to 4s equal to 4 seconds. Okay, equal to 4 seconds. So what is it? We get minus 6 times 4. That is, we obtain that the acceleration is equal to minus 20 meter per second squared. So what is the negative sign? The negative sign means that when, for this case, we set up, go to the right as a positive. Okay, we normally set up the positive direction follow with the initial velocity. Okay, and for this case, the particle is travel along the straight line to the right. So then to the right is a positive. Okay, so then it's mean from this equation, after we take the derivative to find a, we obtain the acceleration equal to minus 20 meter per second square. The negative sign means that it's go left. Okay, it's go left. The direction of the acceleration is to the left. It means that this is the deceleration is reduce the speed. That is goes to the right as a positive. Okay, so then we already have the acceleration. Then we move to the position. For position, we know that v equal to ds by dt. Okay, so then it means that ds equal to v dt. Then we integrate both sides. Okay, from the limit of integration, that is when time equal to 0, s equal to s0. Okay, and when time equal to t, s equal to s. So from the left hand side, we have s minus s0. And for the right hand side, okay, we have to integrate this term. The velocity function, we know that the velocity function is equal to 4t minus 3t squared dt. Okay, we integrate this equation, we obtain that 4t squared over 2 minus 3t cubed over 3. Okay, so the limit of integration is from 0 to t. Okay, so according to this, we have s minus s0, and this should be 2t squared minus t cubed. Okay, and from the problem give us that when time equal to 0, s equal to 0. So then it means that s0 is equal to 0, right? Okay, so from this, we obtain that s equal to 2t squared minus t cubed. Okay, and when time equal to 4 seconds, okay, substitute time equal to 4 seconds to this equation, we obtain s equal to 4 squared minus 4 cubed, and it's become minus 32 meter. So what does it mean? It means that is go to the position of the particle is to the left. Okay, it's to the left, it's not to the right. Okay, and then we move to next example. The next example is the car as shown in the figure move in a straight line such that for a short time its velocity is defined by this function t squared plus 2t. Okay, we would like to determine the position and acceleration. Okay, position and acceleration when time equal to 3 seconds. When time equal to 3 seconds, and at time equal to 0, s equal to 0. You see that this problem and the previous one is very close to each other, but for this case, this is a car. The previous one is a particle. So we do the same thing. We do the same thing for acceleration. For acceleration, we know that a equal to dv by dt, and we take the first derivative of this function, that is 3t squared plus 2t. Okay, the function of velocity is given like this. Okay, so according to this, we have acceleration function is equal to 6t plus 2. Okay, so then when time equal to 3 seconds, Okay, it means that acceleration is become 6 times 3 plus 2. Okay, and it's become 20 foot per second square. Okay, it's positive. It means that is to the right. Okay, to the right as the as we set up right as a positive one. Okay, and when we would like to determine the position is we use the kinematic equation of the v equal to ds by dt. Okay, and we know the function of v as 3t squared plus 2t. Okay, so then this means that integrate ds from s0 to s equal to integrate v dt. That is right now v is equal to 3t squared plus 2t dt. Integrate from time equal to 0 to time equal to t. This is s minus s0. But we know that when time equal to 0, s equal to 0, it means that s0 is equal to 0, right? So it's become 0. And we integrate this term, we get okay plus 2t squared over 2. Okay, and limit of integration is from 0 to t. Okay, so according to this, we have s equal to t cubed plus t squared. Okay, we substitute when time equal to 3 seconds. Okay, we obtain s equal to cube plus power 2. That is become 36 foot. The positive is mean that the position is to the right. Okay, it's complete for this problem. Okay, let's take a look for next problem. Okay, our next problem is a particle is moving along a straight line with the acceleration. Now we know the acceleration. Acceleration is as a function of time like this. It's not constant. Time is in second, and we would like to find velocity and position. Velocity and position. So we starting with know that the kinematic equation of dv by dt equal to a, right? Okay, so then see that v is equal to dv equal to a dt. Okay, we integrate both sides. We have equal dv. Okay, equal to integrate a dt. Right now, a is equal to 12t minus dt. Okay, dt. Okay, we integrate from t equal to 0. Okay, t equal to 0 to t equal to t. Okay, when time equal to 0, v is equal to 0. And we have to know that when time equal to 0, s is not 0. S is 15 foot. Okay, so we have to be careful this. This is S0 is not equal to 0 anymore. Okay, so the limit of integration for dv is from 0 to v, because when time equal to 0, v equal to 0. So according to this, we have v equal to 60, okay, minus 2t power 3 over 2. Okay, the limit of integration is from 0 to t. So then we have the velocity function. We would like to find the velocity function. Okay, that is how we have that v is equal to 6t squared. 6t squared minus 2t power 3 over 2. Okay, foot per second. This is the velocity function that we obtain. Okay, for the position, In order to determine the position, we use this kinematic equation that is dv ds by dt, sorry. ds by dt equal to v. And according to this, we set up to the right as a positive. Okay, and we have integrate ds from s0 to s, okay, equal to integrate v dt, okay, from 0 to t. But now we know that from the problem, s0 is equal to 15. So then be careful to substitute 15 for s0 s, okay, and it's equal to 0 to t. The velocity, we use this equation that we already derived, 6t squared minus 2t power 3 over 2 dt. Okay, so according to this, we have s minus 15. Okay, don't forget this term. Okay, and it's equal to 2t cubed minus, okay, 4 over 5 t power 3 over 2. Okay, this is the calculus. Okay, we integrate this term, right? We integrate this term, it's become 3 power 3 over 2 plus 2 over 2, right? Okay, and it should be divided by 3 plus 2 is become 5 over 2. Okay, 5 over 2. So then it's become 4 over 5 t power 5 over 2. Okay, you're right. We have this term. And the limit of integration is from 0 to t. According to this, we have the equation of s, okay, that is equal to 3 cubed minus 4 over 5 t power 5 over 2, and then plus 15. Okay, do not forget this term, that is the limit of integration. That is for this case, s0 is not equal to 0. So do not forget that. Okay, that it should be complete for this example for the case of the kinematics, rectilinear kinematics problem. That is for the case that the acceleration is not constant. Okay, so then next topic we will talking about the erratic motion. Okay,